So today we'll learn how do we find the modes algebraically and graphically. So we will take the same example that we worked on yesterday. So we did this. We have the classes here, the intervals, the frequency of each class, and so on. So let's learn how to find the mode algebraically first. Okay, to find the mode algebraically, first of all, you find the model class. Model class, we said the model class is the class with the highest frequency. So you look at the frequency column. The highest frequency was 70, so the model class is a 3 4. Okay, so 3 4 is my model class. Since I can't know what is the mode here, the most frequent one used, because it's an interval, it's not a specific variable. That's why you have to use a formula to find the mode algebraically. How can we find the mode? The formula is mode equal the lower bound, so LB means the lower bound of my model class. Why we are looking at the model class? Because you are finding the mode, so you have to look at your model class plus the frequency of the next class next to the model class, I mean, over the frequency of the next class plus the frequency of the previous to the model class times, so times I means the amplitude of the class. Okay, so the modes equal, okay, lower bound of model class, so this is my model class here. Okay, what is the lower bound? We said that the lower bound is this one, A, so 3 here. Okay, and 4 it's called the upper bound. So the lower bound here is a 3 for the model class, so you write 3 plus the frequency of the next class. So here is my model class, so you look at the table 3 4. Okay, now you want to find the frequency of the next class next to the model class. So here is my model class. The next class after the model class is this one, so you want to find its frequency. Okay, the frequency of the next class next to the model class. Okay, once you find the model class, you look at the class after it. It's 4 5. The frequency of this class is 20, so plus 20 over the frequency of the next class, which we already found it, which is 20, plus the frequency of the previous class. So you look at the model class and then you find the frequency of the class before it, the previous one. So the previous class was 2 3, its frequency is 40. So here is the frequency of the previous class. Okay, so this is my model class, this is the class next to it, has frequency 20, and this is the class before the model class which has the frequency 40. So here you have to add 40, so plus 40 down, okay, times the amplitude. So what is the amplitude of the class here? So times, okay, the amplitude was what? How do we find the amplitude? You just subtract the boundaries. Here the amplitude is 1, okay? The interval is a 3, 4, so the amplitude is b minus a, which is 4 minus 3, it means 1. You just subtract the values of the interval b minus a, so here it's 1. Okay, it's not always 1, the amplitude, but in this example it is 1. Then you calculate, use your calculator, so 3 plus this times 1, you will get 3.33. So this is how we found the mode algebraically. You use this formula. You find the model class, the class with the highest frequency. Then you find the mode by using this formula here. It is the lower bound of your model class. So here it's 3 plus the frequency of the class after the model class. So you look at your model class, you look at the frequency of the class after it, which is 20, divided by the frequency of the class after the model class, which was 20, plus the frequency of the previous class, previous to the model class I mean, which is 40, times the amplitude of your interval. You just subtract the boundaries to find the amplitude, which is 1 here, and then you calculate. Now how to find the mode graphically? First of all, you have to graph the frequencies of each class. Okay, so you look at these two columns here. Okay, and you have to graph them using the using a histogram. What do you mean by histogram? So first of all, you you take a scale here. Okay, 0, 1, 2, 3, 4, 5. Why I stopped at 5? Because as you can see here, the intervals start from 0 and it ends at 5. So the classes here are from 0 till 5, and you always put the classes down on the x-axis. So here are my classes, okay, and up you put the frequencies. So the frequencies were 20, 50, 40, 70, 20. So what I made, I took a scale, I moved 10 by 10 because I want to stop at 70. The highest frequency here is 70. So this is how I made it. So the first box is 10, then 20, 30, 40, 50, 60, 70. Okay, you can take the scale that you want, but you have to reach 70 here because it is the highest frequency. Then you look at each class. So 0, 1, from 0 till 1 the frequency is 20. So from 0 till 1 the frequency is 20. You make a rectangle till 20. Okay, the next one, from 1 till 2 the frequency is 50. So from 1 till 2 you go up till 50 and you make your rectangle. Then 40 for the next class, from 2 to 3 it's 40. Okay, so from 2 till 3 you stop at 40, you make your rectangle, and so on. Okay, so this is called a histogram. So if I ask you to draw the histogram of frequencies, you graph it like this. So this is a histogram. You put here the classes, okay, from 0 till 5 we have it, and here you put the frequencies up. You take the scale and then you make rectangles depending on the frequency of each class. Now how can we find the mode? We know that the mode has, or it's located in the class with the highest frequency. Okay, we know that the mode is the most frequent data. So here the model class, or the mode with the, we cannot say mode, so here the model class is a 3 4, because as you can see graphically it has the highest frequency, 70. So you look first at your model class. Okay, I highlighted it in red. So this is my model class. It was 3 4. It's clear that it has the highest frequency, so this is my model class. Then what you have to do is to join the vertices of this model class. So you have to draw a segment. So we have this vertex here, and you connect it to the opposite vertex of your rectangle. Okay, so this is my first segment, and the other segment is you join this vertex with the end of, or the beginning of the next rectangle. So here you stop here. Okay, so I made two segments joining the vertices of my rectangles. Okay, so we drew two line segments joining the vertices of the longest rectangle that has a highest frequency. Then you look at the point of intersection here of the two segments, and you draw a vertical line that cuts your x-axis. So of course use a ruler. I will draw a dotted line. Wait. Okay, so this is the intersecting points of the two segments. I made a dotted line, vertical dotted line. Okay, it intersects the x-axis at this point. Now you give an approximation of this point. This point is the mode because it's located in the model class. Here the model class was 3 4, and this point here, the x coordinates of this point, is the mode. So it's about 3.3 as you can see here. Of course, use a gridded paper to find an approximation of the mode. If you put 3.4, 3.2 is okay, it's an approximation, but not more than that. So the mode here, I will write it down. The mode graphically is about 3.3. Okay, so this is how we find the mode graphically, and algebraically you just I just show you how to use the formula. Okay, thank you.